Hello students, in this video we'll prove the law of cosines. Let's be given a triangle A, B, C, and what we'll do is we'll take the triangle, and I'm going to consider a circle, and A is going to be the center of this circle. That's always possible. And then I'm going to choose this triangle in such a way so that the point over here, B, is the point on the circle itself, and that C is somewhere else in the middle, interior to the circle. So we can always configure our situation so we have a circle, we have a triangle that's inside a circle like this. And there's the point C. So this angle over here is gamma, this angle over here is alpha, this angle over here is beta, this is the side length of C, this is the length of B, and this is the length of A. So there we have it. So what I can do now is I can add a whole bunch of different lines in my triangle. So let's add this line over here that goes from, continues the diameter of the circle. We can call this point over here D. Then this length will also be C because that's another radius of the triangle. We can take this line AC, since it's inside the triangle, and extend it out. So I get another radius, so that's also going to be a C. And then I can continue that over here to a point over here. Let's call that point E, and let's call this point over here F. And now I'd like to find out some of these lengths over here. So notice that from A to E, so AE is a radius, so AE is equal to C since it's a radius. AD, these lengths, AD is equal to C since it's a radius. And I know that AF is equal to D, so AF also has to be equal to, not D, but AF has to be equal to C, because AF is a radius. So all of these are radii of the circle. These are all radii of our circle. And now I can find out what CF is. So CF, the length of CF, plus the length of AC has to be equal to C, because that total length is a radius. Now, we know that AC is equal to B, so this is B over here, so we can find out what CF is going to be. So CF has to be, that length CF is going to be C minus B. So this length over here is C minus B. And then one final line to add over here. I'm going to add this blue line, which connects the line from B to C up to the circle. And that's the last point. So let's see, I have A, B, C, D, E, F, and then here's the point G, right? And I'm going to connect G to D. And now since I'm connecting the point from B to G to D has to be a right angle, because that is sweeping out half of the circle. It basically intersects with a diameter, so this is 180 degrees, or pi radians, so this angle has to be half of pi, or pi over 2, or 90 degrees. So now I have a right triangle with an angle of B. So what I'm going to do now is I am going to use some trigonometry. I know that the length from B to G, so from B to G, that length, will have a hypotenuse of 2c. That's my hypotenuse of this triangle. And that is the adjacent side to the angle of beta. So that will be 2c times the what? Times the cosine of that angle beta. So that's the whole length over there. So now I'm able to actually compute what this length from G to C is. From G to C, well, I know cumulatively that G to B is going to be equal to what? G to B we just found to be 2c cosine B. And so now they have an A over here. So G to C has to be the whole thing. So GC plus, let's do GC plus, this might be a little bit easier to see. So GC plus BC, or CB, is going to be equal to BG, and that's equal to 2c cosine of beta. Therefore, but we know what CB is. CB is equal to A, so that tells us that GC is equal to 2c cosine beta minus A, because this over here is equal to A. And so now I'm in a position to apply the power of a point theorem. So now let's look carefully. So the power of a point theorem says wherever you see an x in a triangle, you get a corresponding product. So I know the product over here of CB, this F to C, and this C to E, that is one part of my x. So by the power of the point, by power of point, we know that C minus B times B plus C has to be equal to what? Has to be equal to, over here it's going to be a, this length over here is a times this length over here, which we just found. So that's going to be a times the length g to c, which is going to be 2c cosine beta minus a. So the power of point theorem gives us this relationship between a, b, c, and the cosine of beta. And so now let's multiply this through. What this left-hand side will be is this left side is going to be c squared minus b squared, and there are no cross terms because I'm going to have a positive a b times c and a negative b times c, so those will cancel out. So the left-hand side is c squared minus b squared. And now what's the right-hand side? The right-hand side over here is going to be a 2ac cosine of beta minus a squared. Now I can rearrange this and write this in the following way. I can write this as a squared plus c squared minus 2ac cosine beta is equal to b squared. And this formula over here is the law of cosines. In some textbooks, they like to have a c squared is equal to a squared plus b squared minus 2ab cosine of gamma for the c angle. It doesn't matter. It just happened to be the labels I put on my vertices in the triangle. So it doesn't matter what vertices you choose. As long as you have the right labels, this will give you the law of cosines. So remember, the law of cosines can come geometrically from the power of a point. Thank you very much.